Okay, so let's do question number 9 of the tutorial. So for this circuit here, so we have to determine the current I1, I2, and I3. So they don't draw the direction of the current, we just have to do it ourselves. And then we have to calculate the number of electrons passing through the 9 ohm resistor in 2 seconds, power dissipated by the 5 ohm resistor, energy supplied by the 7 volt battery in 2 minutes. And lastly, change in the resistance of the 2 ohm resistor when there is a 30-degree rise in its temperature. Okay, so let's first start by drawing the direction of the current. So what I'm gonna do is I would let I2 to be pointing here, and then at this junction they will go out. Two currents will go out of the junction, which is I1 and I3 lah. Okay, so that is basically the direction of the current. And then what I would like to do is I always draw the current punya direction above the resistor that is on the circuit lah. Okay, supaya kita senang tengok direction of the current bila kita mau solve the question. And then for this one, it's gonna be I3 lah. So you can label them. This one is I1, this one is I2, and this one is I3. So this current will be I1 as well, whereas this one is I2 and this is I3. So after that, I would draw the direction of the EMF. So it's gonna be from the negative to the positive terminal, and then this one as well, and this one here. So after drawing the direction of the EMF, what we can do is we can designate a direction of the loop. So the first loop, I'm gonna follow the 7 volt punya direction, which is gonna be clockwise. So let's do a square here just to tell the direction of the loop. Okay, do the same thing here. So you can either use the 3 volt punya battery punya direction or the 8 volt. So it's entirely up to you. But I'm gonna use the 3 volt punya direction. So this will be anti-clockwise lah. Okay, so we designate a direction of the loop. Now we can start by applying the Kirchhoff's first rule and second rule lah. Okay, so this is question A. So at junction A, we have total current going in equal to the total current going out. Okay, so it's gonna be I2 equal to I1 plus I3. So this is equation 1. So after that, we are gonna apply the Kirchhoff's second rule, which is the total EMF equal to the total product of current and resistance. Okay, so let's look at loop number 1. So this is our first loop, this is our second loop. So the current going so we are going to look at the EMF first. So we have two EMFs. We have the 7 volt and the 3 volt punya. So this is following the direction of the loop, so it's going to be positive 7 following the direction of the loop as well. So 7 plus 3, so that is the total EMF equal to the product of current and resistance. So we have two resistors here, so we're only gonna have dua di right hand side punya equation lah. Okay, so it's gonna be positive 2 I1 because it's following the direction of the loop. Similarly, for the 9 ohm resistor, it is following the direction of the loop as well, so it's going to be 2 I1 plus 9 I2. Okay, so 2 I1 plus 9 I2. So this is going to be 10 2 I1 plus 9 I2. So this is our second equation. Now let's look at the second loop. So it's going to be 3 plus 8 for the EMF. So this is 3 plus 8 equal to so 3 plus 8 equal to 9 I2, positive 9 I2, positive 9 I2 plus 5 I2. Okay, so it's gonna be 9 I2 plus 5 I2. So this is 11 equal to 9 I2 plus 5 I3 lah, sorry. This is I3. Oopsie. This is I3. So now we are gonna try to let this, let equation 1 to be I1 equal to I2 minus I3. Sebab sekarang ni kita ada 3 unknowns. I1, I2, and I3. So, kita mau ada 2 unknowns dulu supaya kita boleh solve salah satu saja. So, this is gonna be our third equation lah, basically. Kan? Fourth equation. So, this is our third equation. This is fourth equation. So, we can substitute equation 4 into equation 2. Kita mau substitute di mana? Equation 2 kah? Ya, kita substitute di equation 2 dulu lah. Okay? So, it's gonna be 10 equal to 2 I2 minus I3 plus 9 I2. So, this is equal to 2I2 minus 2I3 plus 9I2. So, solve this until kamu dapat one equation. So, I'm gonna let I2 equal to 0.909 plus 0.182 I3. So, this is our fifth equation. So, what we are gonna do is we are gonna substitute this fifth equation into our third equation. Supaya kita dapat satu saja unknown lah. So, this is going to be 0.909 plus 0.182 I3 plus 5I3. Okay? So, di sini kamu akan dapat 8.181 plus 1.638 I3 plus 5I3. So, solve for I3. You should get something like this lah. 11 minus 8.181 over 1.638 plus 5, which will then equal to 0.425 ampere. So, dapat sudah I3, barulah kita boleh substitute I3 into equation 5 tadi. Okay, kenapa kita substitute situ? Sebab kita mau cari nilai I2 lah. So, this is 0.909 plus 0.182 times with 0.425 lah. So, this will be equal to 0.986 ampere. So, sekarang baru kita boleh substitute I2 and I3 into equation 4 tadi. Okay, supaya kita dapat I1 lah. So, it's gonna be 0.986 plus 0.425, which will then give us 0.561 ampere. Okay, so that is on question A. Question B pula, we have to calculate the number of electrons passing through the 9 ohm resistor. So, sekarang ni kita focus on the 9 ohm resistor. We know that Q is equal to IT and Q is also equal to NE. So, we can do NE equal to IT. So, what is the current flowing through the 9 ohm resistor? It is I2. So, kita label di sini sebagai I2. So, N is equal to I2T over E, which is equal to what is I2 tadi? 0.986. 2 minutes. 2 seconds. Divide by the charge of electron. Then you will get the number of electrons to be equal to 1.23 times 10 to the power of negative 19 electrons. Okay, so that is question B. Question C, power dissipated by the 5 ohm resistor. We know that power is equal to IR. So what is the current flowing to the 5 ohm resistor? It is I3 and the value of R is 5 ohm. So we can just directly substitute lah dalam this equation here. So I3 is equal to 0.425 times with the 5 ohm resistor. So you'll get the power dissipated through this 5 ohm resistor to be equal to 0.902 ohm. Okay? Power lah dia minta. This is what? Tertengok the... Never mind. Okay, so that is question C. Question D pula, we have to calculate the energy supplied by the 7-volt battery. Energy supplied by the 7-volt battery in 2 minutes. So we know that energy is equal to VIT. So what is the current flowing through the 7-volt? It is I1. So it's going to be I1 here. So V is 7, I1 is 0.561 times with the time, which is 2 minutes, so 2 times 60, because we need it in seconds, so it's going to be equal to 472 joules. Okay, so that is the energy supplied by the 7-volt battery. And then we have to calculate the change in the resistance of the 2 ohm resistor. 2 ohm resistor when there is a 30-degree rise in its temperature. Okay, so that one, it's gonna be dia minta apa? Change in the resistance. So it is asking about delta R lah. Okay, so delta R, so delta R is basically R minus R naught kan. So sekarang ni kita tahu R is equal to 1 plus R naught 1 plus alpha T minus T naught minus R naught. Okay, so dia cakap ada 30-degree rise, so T minus T naught is basically delta T, which is equal to 30 lah. Okay, so our equation becomes R naught, after simplification dia jadi R naught alpha delta T, where delta T is equal to 30 degree Celsius, sebab dia cakap ada 30 degree rise. So sekarang ni I'm just gonna do it here because tidak muat sudah. So delta R is equal to R naught, which is 2, and then alpha 6.8 times 10 negative 3, delta T is 30, which will then equal to 0.408 ohm. So that is the change in the resistance value when there is a 30-degree Celsius temperature rise. Okay, so this is the solution for question number 9.